Hello everyone. In this video I will explain how to draw development of lateral surfaces for a prism. So first I will explain what is development of lateral surfaces. So this is a pentagonal prism. We can see here there are 5 vertical rectangular faces, and here I have not drawn top face and bottom face because we have to draw development of lateral surfaces only. Lateral surfaces means vertical surfaces. We will not consider top surface and bottom surface of the prism. So here if you unfold this prism, then how it will look? That is nothing but development of lateral surfaces. So if I unfold this prism, then it will look like this. There will be 5 rectangular surfaces as this is the pentagonal prism. So this is nothing but development of lateral surfaces. Now if you cut this prism by cutting plane at certain inclination to the axis, then it will look like this. So it is the pentagonal prism which is cut by cutting plane at certain inclination. Now if we unfold this, then it will look like this. So this is the development of lateral surfaces. So upper part we have removed by a cutting plane. So it will look like this. Understanding of development of lateral surfaces is very important because if you have to manufacture any product like prism by using sheet metal, then first we need to cut that sheet metal in required shape and then we can fold to get the required shape like this. Now let us consider an example. A pentagonal prism, side of base 30 mm and axis 50 mm long, is kept on horizontal plane in such a way that one of its base edges is parallel to vertical plane and near to the observer. A cutting plane bisects its axis at 20 degree. Draw the development of lateral surfaces for the pentagonal prism. So this is the first quadrant in which this is vertical plane and this is the horizontal plane. This is the pentagonal prism. So if you observe this pentagonal prism, it is having vertical rectangular faces and top and bottom face is pentagon in shape. This is the top surface which is having pentagon shape and bottom surface also pentagon in shape. Now here in example, dimensions of the pentagon is given. Side of base 30 mm means each side of this pentagon it is 30 mm, and we know interior angle between two successive edges of the pentagon it is 108 degree, and axis length is given. So axis length is nothing but height of the prism. So height of the prism and base side it is given. So we can draw its front view and top view. Now further it is given that it is kept on horizontal plane in such a way that one of its base edges is parallel to vertical plane. So there are 5 edges to base of this prism. So one of its edges, let us consider this edge. So this edge should be parallel to vertical plane. So if you keep this pentagonal prism base like this, then this edge is parallel to vertical plane. We can also keep this base like this, so that this edge is parallel to vertical plane. But here it is given that parallel edge should be near to the observer. So observer will be at this point. So if base is kept like this, then this parallel edge will be near to the vertical plane and away from the observer. And if you keep the base like this, then this edge is parallel to vertical plane as well as it is near to the observer. So we need to keep the pentagonal prism like this only. Now we have to draw its front view and top view. So intersection of vertical plane and horizontal plane, it is the xy axis, and when we look at the object from the top direction, then observer will observe the pentagon shape, and that pentagon shape we can draw in top view like this. And this edge is parallel to xy. So when we are drawing top view, this xy line will act as the vertical plane. So this line is parallel to xy, means it is parallel to vertical plane, and here on this side it is vertical plane and on this side there will be observer. So this parallel line will be near to the observer, and these are the other edges of the pentagon. Now we can draw the front view. So if observer look at the object from this direction, then observer will look the object like this, and we can draw the edges of this pentagonal prism like this. So this is the front view and top view. Now if this is the sheet on which we have to draw the development of lateral surfaces, then we need to draw this front view and top view on left side of the sheet, so that we can draw development of surface on right side of the front view. So first we will draw top view. As base of the prism it is pentagon in shape, then that shape we have to draw first, means we have to draw top view first. So here we have to draw one of its base edges parallel to vertical plane and near to the observer. So this xy line is vertical plane and observer will be on this side. So on this side we can draw horizontal line which is parallel to xy, and length of this line will be equal to 30 mm. Then we can draw another line inclined at 108 to this horizontal line. So we can draw a line of 30 mm length at 108 inclination. Similarly on right side also we can measure angle 108 degree, and we can draw a line of 30 mm length. Then to draw remaining two lines we can use compass, or it is also called as rounder. Take rounder and take distance is equal to 30 mm, that is distance is equal to side of base, and from this corner we can draw one arc like this. Similarly by using same distance we can draw intersecting arc from right side. So we will get one intersecting point, and we can connect this point to the edges like this, so that pentagon will be completed. So in this way we can complete the pentagon in the top view. Then to draw the front view we can take the projections of each point in the front view, and here axis length is given. So axis length of prism is nothing but height of the prism. So we can measure 50 mm distance, and we can draw vertical edges of the prism from each corner. So from this corner we can draw 50 mm, from this also it is 50 mm, from this also it is 50 mm, and from this also it is 50 mm. This edge it is at back side, so we can draw hidden line. First we will complete this top surface, this is bottom surface. Here for this corner edge will be at back side, so it will be hidden line. Also if you draw axis of the prism, then it will be passing from the center, so it will be like this. So that hidden line for this corner will be coinciding with the center line, so I will draw directly center line instead of dashed line. But if center line and dashed line are not coinciding, in that case we need to draw dashed line also, that is line for hidden edge. Now here we have drawn pentagon like this because one of its base edges is parallel to vertical plane. But suppose instead of parallel, if it is perpendicular, then in that case we need to draw pentagon like this, and we can complete the front view by taking the projections like this, and height is equal to 50 mm. But here when we have to draw the axis, then that center point we have to locate in the top view first. So to draw center of the pentagon we need to bisect any two angle of the pentagon. So if I bisect this angle, so it will be horizontal line, and if I bisect this angle it will be intersecting at this point. So this is the center of pentagon, and from this projection we can draw the center line for the pentagon in the front view. So this is the previous case in which this edge is parallel to vertical plane. Now we have to draw the development of lateral surfaces for this prism. So first we will give the names to each corner of the prism, A, B, C, D, E, like this. So this is for base pentagon. So its projection in the front view we will get. So E will be E dash, then A dash, then D, D dash, B, B dash, C, C dash, like this. And for top pentagonal surface we can give the numbering 1, 2, 3, 4. So we can start from 1, 2, 3, 4, 5, and from these projections we can write here this 1 will be 1 dash, this 2 will be 2 dash, this 3 will be 3 dash, then this 4 will be 4 dash, and this 5 will be 5 dash. So for base pentagon we have given A, B, C, D, and for top pentagon we have given 1, 2, 3, 4. We can give any names. Then here we have to draw the development of this prism, and here we have to use the parallel method because it is prism. So for prism we have to use parallel method, and for pyramid we have to use the radial method. So we can take projections of all points from the front view on this side like this. Then if you unfold this prism, it will be having 5 rectangular faces. Now we have seen that if you unfold this prism, it will be having 5 rectangular faces as it is pentagonal prism. So here also we will draw the 5 rectangular faces, and what should be size? So width of each rectangle is 30 mm and height it is 50 mm. So we can use compass, and on these projections we can mark the points at 30 mm each like this. So from each points we can draw vertical lines and we can complete the 5 rectangular faces. So this is the development of lateral surfaces of the pentagonal prism. So here we can give the names A, B, C, D, E and again A. Here also 1, 2, 3, 4 and again 1. So this is not simple prism. A cutting plane bisects its axis at 20 degree. So this is the axis of the prism, and height of this axis it is 50. So it is bisecting by cutting plane means at mid of this axis we can draw that cutting plane. So we can measure 25 mm distance and we can locate that midpoint of the axis, and from this midpoint we can draw a cutting plane at 20 degree inclination. So this is the cutting plane, and when we cut this prism, that upper part we have to remove and lower part we have to keep, and for that lower part only we have to draw the development of lateral surfaces. To draw that development, from each intersections point we can draw projections like this. Now this cutting plane will intersect this E5 line, E5 line. So here it is E5 line. So from this intersection this projection is coming. So here we can locate that point on E5. Then this cutting plane intersecting this A1 edge at this point. So at this A1 we can locate the point, and on this side also we can locate the point. Then this cutting plane intersecting this D4 line. So here we can locate that point. This is the intersection of the cutting plane with this B2. So from this projection we can locate the point here on B2 line. Then here it is C3 line which cut at this point, C3. So we can locate that point here. As we are removing upper part, lower part we have to draw by thick lines. So top view will be thick lines, pentagon will be visible from the top, and below this cutting plane this will be dark like this. So just connect these points like this. This edges also visible, so we can draw these edges and this bottom line. So this is the development of lateral surfaces of the pentagonal prism when it is cut by cutting plane, and we have drawn this by unfolding from corner A. Now instead of A, suppose if we unfold by taking unfolding point from E, then development of lateral surfaces will be slightly different. So here numbering will be starting from E instead of A because we are unfolding from E point. So here we can write E, A, B, C, D and again E. So first point and last point will be same. Similarly at top side also it will be starting from 5. So 5, 1, 2, 3, 4 and again 5. Now as names are changed, point will also change. This cutting plane will intersect E5 line at this point. So from this projection we can locate the point on E5 at this end. Also here it is E5 line, so we can look at that point here. Then this cutting plane intersecting A1 line at this point. So from this projection we can locate point on A1 line. Then this B2 edge will cut at this point. So from this projection we can locate the point at this B2 line. Then C3 edge will cut at this point. So from this projection on C3 we can locate the point. And on back side this D4 edge will cut at this point. So we can locate that D4 here. So in this way we can get all points. Now we will join these points like this. Also we can draw the lines for the corner edges and this base edge like this. So this is the development of lateral surfaces when unfolding point is E, and this we will get when we are unfolding from point A. So shape will be slightly different. So if unfolding point is not given, try to take leftmost point as a unfolding point and draw the development of lateral surfaces. Now if cutting plane inclination it is more, then that cutting plane may pass through top surface and bottom surface, depends upon angle and point of intersection on the axis. So if it is intersecting top surface and bottom surface, in that case see how to locate the points. So this cutting plane intersecting vertical edges at this point, at this point and at this point. So these 3 points we can locate similar to previous case. So here when we are cutting this prism by cutting plane like this, then upper part we have to remove and lower part we have to keep, and lower part we can make dark like this. And this cutting points of the vertical edges we can locate similar to previous case by drawing projections. So here this line is A1. So on this line we can locate that point. So D4 edge will intersect at this point, so we can locate D4 point here. Then B2. So on this B2 we can get the projection here, so we can locate that point here. So these 3 points we can locate similar to previous case, but how to locate the points at top surface and bottom surface? So for that purpose we have to take the projection in the top view like this, and this cutting plane will intersect the top surface pentagonal line, that is 3 4 and 2 3 lines at these points, and these points we have to locate here. And here also this cutting plane intersecting bottom surface at this point, so bottom pentagon will cut at this point and at this point. So these 4 points we have to locate. These 2 points it is for top surface, and these 2 points it is for bottom surface. So to locate these points, make use of this compass. So measure distance of this point. So this is D line, and on this D line take distance in compass from E towards D. So this distance we have to take from E towards D on baseline on bottom surface. So from E towards D we can measure the distance and we can look at the point. Similarly, we can measure the distance of this point. So we are measuring distance from A on line AE, from A towards E. So this is AE line. So from A towards E we can measure the distance here. So here we will get that point on this bottom surface line. Similarly, we can measure distance for top surface edges. So again by using compass we can measure the distance of this point, which is on line 2 3. So this is line 2 3, and on this 2 3 line we are measuring distance from 2 towards 3. So this is 2 3. So from 2 towards 3 we can measure the distance and we can look at the point here. Similarly, we can measure distance of this point. So this is the line 3 4. So this is 3 4 line, and on this 3 4 line we are measuring distance from 4 towards 3. So from 4 towards 3 we will get point here like this. And now we can connect the points. So here we will take unfolding point as E, that is leftmost point. So from this point we can start connecting like this, and this is bottom line, and for vertical edges also we can draw the lines like this. and this remaining portion is included in the upper part, so that part we have to remove. So this is the development of lateral surfaces when cutting plane cut the top surface and bottom surface. We can also draw the top surface like this. So only this part will be removed. So complete pentagon will not be visible. It will be look like this. This corner will remain as it is, but this cut at the top surface we have to show here. And if you try to draw its sectional view, then it will be like this. Thank you.